Hello and welcome to the tutorial video for focus quizzes 24 through 25, which is this is really a tutorial video for focus quiz 24 because focus quiz 25 is a summary quiz. I've requested that you don't get the long 35 question one, only the 10 question one, which has easier questions because I'm kind, and we will be using the other one later. Don't worry. I know you're excited. Anyways, this is pretty much just going to go over this first bit you see here, and then I'll just give you a quick pep talk slash explanation of what will be on that section 2 summary. Alright, so this is very similar to last week's quiz, whereas that was properties of angles with certain lines you can do on circles. This is properties of lengths of lines that you can do on circles. So these are tangent lines. I don't really remember if those came up last week at all, but a tangent line is one that goes from a point across the surface of a circle. So you can imagine if you had like a stick and you just had like a some sort of wheel here, and you laid the stick on top of the wheel and it was held up by some point, that would be a tangent line. It just brushes the circle right there. And if you have multiple tangent lines coming from the same point, they are the same length. So this tangent line with length x and this one with y, x is going to equal y. I don't even think that comes up on the quiz, but it will come up eventually, I promise. So remember it. And it kind of makes sense, right? If you take two sticks from the same place, put them on the same wheel, they're going to meet the wheel at the same length on the stick. It looks correct, so, you know, probably is correct. The more important thing about tangents for this one is that a tangent line like this, where it meets the edge there, is always going to be perpendicular to the center of the circle. If you form a line between the point it meets there, let's call this Q, and this O, this angle is always going to be a right angle. And you probably know that right angles are always going to probably lead to Pythagorean theorem. So let's look at this, and this has to do with the right angle part of that theorem. A point P is 10 centimeters away from the center of a circle. So let's draw a point here. It doesn't really matter. Label it P. And then it says it's 10 centimeters away from the center of a circle. So this length is 10 centimeters. The length of the tangent drawn from P to the circle is 8 centimeters. So we could either draw from here to here or from here to here. I'm going to go up because we labeled down there already. It doesn't have to be perfect. You just need to know it's a tangent. It's very difficult to draw perfect tangent lines. Find the length of the tangent drawn. Oh, sorry. Find the radius of the circle. So the radius is going to be this line here, right? And we know this is a right angle. This is 8 centimeters, should have labeled that before, and we can find, with this being our hypotenuse, that 10 centimeters, we can find this length x, r, whatever you want to call it, using Pythagorean theorem. So 8 squared plus x squared equals 10 squared, so 64 plus x squared equals 100. Subtract away that 64, and we're going to get, what? 36? Yeah. X squared equals 36. So x equals 6, square root of 36. And that's basically just a really roundabout way of giving you a Pythagorean theorem problem, which hopefully you got that down pat, because it'll come up forever for the rest of your life, for all time. It's pretty useful. I just want to say Pythagorean theorem is one of the few things that you learn in like advanced math classes that I have found myself using outside of learning more math, for measuring out projects, understanding how much wood you need to buy for something, how long some part of a driveway is going to be, anything like that. It actually is useful and not difficult to remember, so try to remember it. If AP and AQ are tangents from an outside point A. So let's start drawing that. Say this is A, and this is a P, and a Q. That's fine. Those are equal length. You're not going to always draw it perfectly correctly, especially not me on a tablet, but those are our lines, such that AP equals 7 centimeters, and PAQ, so PAQ, this angle is 60 degrees. Find the length of the chord PQ. Alright, so at first you might be thinking, what? What do you do for this? And there are a couple ways you could do it. My first instinct was to split this right here and get a 30, 60, 90 triangle. But the actual easy way to do this is to realize that if the angle of a triangle is 60 degrees and two of the other sides, so we know the tangents have to be equal, so I guess that property does come up here. If these two sides are equal, this is at least an isosceles triangle, but if this is 60 degrees, these two angles have to be the same because these two lengths are the same. These are also going to be 60 degrees, which makes this an equilateral triangle, so this length is also 7 centimeters. If I had drawn this more correctly to scale, it would look more correctly equilateral, and it almost does, but that's how you do this problem, and hint, hint, there's a problem pretty much exactly like this on the quiz, so remember this. Oh, I keep doing this. Stuff about chords and the length of them specifically. So these are a couple chords. Chords are lines that are on the inside entirely of a circle. Here is that same picture, but we have drawn some extra lines here and here, and that is just to illustrate part of this property that I'm not going to get too in depth with, that these two triangles formed when you make these lines are similar. They have the same angles and thus proportions, and because of that we can like extrapolate this property here. It looks kind of complicated. It's really not. When two chords intersect inside a circle like these do, the product of the lengths of the segment of one chord equals the product of the lengths of the segment of the other chord. What that means is if you take this length and multiply it by this length, it's going to equal the same thing as this length multiplied times this length. So you could look like this. I think it's a lot easier that AE, so one of the segments of this chord, times BE, the other part, equals DE times EC. And that always holds true. When you split the chord at the intersection point and multiply its two parts together, it's going to equal the same thing as when you do that same process to the other chord. So let's see how that works. This is one that has algebra involved, but it doesn't make it that much harder, especially if you have nsolve on your side. The chords PQ, this one, and RS intersect a point T within the circle. Find X not to scale. So we're just going to do the basic math that we just learned from this. So RS, we split into RT and TS, whatever you want to say, and we're going to multiply that 9 times that 2x. And we know that that's going to equal the other side split and multiplied into its two components as well, which is already done for us, 12 times, and it's important that you do that 4x minus 5 inside of parentheses, otherwise the math will not work, whether or not you use nsolve. So let's throw that into nsolve. Why is Cortana open? I don't use that. Nobody uses that. I'll deal with that in a minute, I guess. Yeah, let's throw this into nsolve. So we have 9 times 2x, right, equals 12 times, I believe it was 4x minus 5, yep, comma x, don't forget that, and we get 2. 2 is what x equals. So we were just looking for x equals 2, but it's important to note that often they will instead ask you, like, what is the length of one of these segments? So if they ask what is the length of RS, that's this whole line, and it would be 9 plus 2x, which is 4, so it'd be 13. This whole line segment would be equal to something, it doesn't really matter. I believe it'd be 15. But you got to make sure you're reading what the question is actually looking for, because they might put 2 as an answer choice, but they're actually looking for 13, which is also an answer choice. Just read the question carefully. The chords PQ and RS intersect at the point T within the circle. The measures of, so this is basically the same kind of problem, but easier. The measures of PT equal 18. We're going to label as we go. RT equals 12, and ST equals 9. Find the measure of QT. So it wants this length here, not the whole line, not anything else, this length here. And we know that 12 times 9, the two components of one chord, are going to equal the two components of the other chord. So we can say 18 times x, whatever you want to call it, And I'll throw this into NSolve because I'm lazy. 12 times 9 equals 18x, comma x, 6. So x equals 6. And just to really prove that, let's try 12 times 9. We're going to get 108. And if we do 18 times 6, we're also going to get 108. It sometimes seems like these maybe are just made up and fabricated, but you're welcome to look in the math resource and see the proofs. I think they're horrid. Well, you know, there's something elegant about them, but I don't like having to learn them, so I didn't think you would either. It's much easier to just memorize stuff like this. But if you do want to know the proofs, go ahead. They're kind of interesting. And if you like took a circle and like a physical circle and measured out to components of chords and then multiplied the measurements, it would come out to be true in the physical world. So I think that's kind of interesting how these things have actual applications. Kind of, at least they are real things. With geometry, you can prove it physically. All right, secants. Secants are chord and tangents ugly baby, where it's just some point outside of the circle, but instead of being nice and going to the edge, it goes all the way through and touches the other side at any point it desires. And this is to show that much like our chord thing, when you have secants, they will form some similar triangles. So these triangles have the same angles, like so, which means they are similar, which means we can extrapolate a property or theorem or whatever from them. And that looks like this. And this looks kind of ugly. This looks really ugly. You're welcome to pause the video and read it. I included it so you can try that. I'm going to describe it how I think about it. I think about this as for each secant, and they have to start at the same point, the little part times the whole is going to equal the little part times the whole of the other one. Which is kind of ugly to look at, but PA times PB, which we can also write PB as PA plus AB, this little part plus this inside part, which is important because sometimes you will not be given the whole length and you need to know that it is the two added together. Pretty intuitive, but just, you know, keep it in mind. Don't get panicked if they don't give you what you think you need. And the same as PC equals, or PC times PD, which we can also write as PC plus CD. They equal each other. So it's very similar to the chord thing, where the two segments multiplied together of these two different seemingly unrelated chords are going to equal each other. Instead, this time though, it is for secants, and it's slightly different. You don't want to split it and then multiply the two parts together. That's not going to get you anything useful, I don't think. Maybe it does. But make sure you're doing the small bit times the large bit. So let's use that. In the given circle, find the length of QS. So it's looking for X. We have, is that something beeping? Oops. Sorry, y'all. I've got stuff open. So we're going to use our properties. 15 is the not smaller outside bit, but it's fine. This is not to scale. 15 times 15 plus 9, the whole line. So 24 is going to equal 12 times 12 plus x. And it's important to keep in mind that you have to add this bit to this bit, and it counts as the whole big thing. Maybe I'm over speaking on that point, but you get it. It is important to remember. So let's go throw this into NSolve again because I'm lazy. You're welcome to do it however you want. And if you are not so fast at typing into your calculator, you probably shouldn't use NSolve for things as simple as this. Or at least you should get a little bit further down the line of algebra before you start throwing it in there. So we found that x equals 18. And just to prove a point, 15 times 24 equals 360, and 12 times 12 plus 18 is 30, is also 360. So just to prove that the property is true, at least for this made-up circle that we made, again, go take a circle, split it up into parts, do whatever. I only did one for this one because it's, you know, essentially it's very similar to the other one. This is the same property, okay? So don't get freaked out. These say what we just went over. GR, the small bit of this secant line, times GQ, the whole thing, equals GZ times GY. Same thing. However, if you make a tangent line from that same point G that the other secants came out of, for some reason, and I don't even think this is in the math resource, but these are older quizzes, so you know, maybe it'll come up. Maybe it's in a later part of the math resource this year, but you need it for this quiz, so remember it anyways. This tangent line squared equals a secant line coming from the same point using the same kind of property that we did before. So all three of these things equal each other. And I'm sure if you found some, like, I bet this is some sort of right angle you can make out of it, blah, blah, blah. It doesn't matter, just memorize that property. So let's use it. And I believe this is the last one for this new series of concepts. OP is tangent, and OQ is a secant to the circle with center T. We don't really care about T. I don't know why they include it, but whatever. Find RQ not to scale. So now we know that if we have a tangent coming from this point, that tangent squared is going to equal the small bit times the whole of the secant made from that same point, which again is, we're just substituting another secant line for the tangent, and we have to square it because I don't know why, but you do. But the other part remains the same for the secant. So this is 5 times 5 plus 4x minus 10. Again, make sure that this is in parentheses, and you add together the two parts as you need to get the whole. And let's end solve that. 15 times 15, 15 squared, whatever, equals 5 times 5 plus 4x minus 10, I believe. Yep. Comma x. 12.5. So x equals 12.5. And that might be an answer choice, but we're not looking for x. We're looking for RQ, which is this line here. So we're going to plug the 12.5 back into this. 4 times 12.5 minus 10 equals 40. So this length is 40. So your answer choice would be 40. That goes over all of these properties, and pretty much that's as complicated as these questions get because there's so much to memorize. I guess they're being kind this time, not making it too complicated. Focus Quiz 25 goes over everything from slope to volume. So it doesn't actually, well, it doesn't have room to include literally a question from every quiz. I find that they're mostly easier if you remember what those previous quizzes go over. So like midpoint formula, slope, volume formula, stuff like that. If you have that stuff memorized, you'll be totally fine on this test, quiz, whatever. If you don't have those memorized, I would recommend that you look at the cram kit. You obviously don't have time to watch all those old videos, but the cram kit, or just scroll through the math resource and look for the parts where they're not proving something and they're actually showing you an equation. And those generally look like this, when they actually show you some conclusion they've come to with an equation in it. You could go through and find that stuff and memorize it. Make some flashcards if you want for all the different simplified formulas. That's what I would recommend. Good luck.